Hi, this is Dan Abbott. I am making this video for the print reading class AEDD 100 at Southern Maine Community College. This is our civil surveying unit in print reading. Someone in the Zoom class today asked me if I'd make a quick video to show you how to do it. That's what I'm doing right now. This is the instruction sheet on how to go about doing this. It comes from a Madsen textbook called Civil Drafting Technology, Madsen and Shoemaker. They've done a lot of books on all kinds of drafting kinds of things. They show you an example right here, and then down here is a test problem. So we're going to go to the example and walk you through that. And I'm going to go back, we'll do that test problem. The whole idea here is you need to know the elevation of something. So in this particular case, the elevation I need to know is right over here. That's my unknown elevation. Now the numbers are there because they've already done the math. Now I know it, I have a known starting point. That's that little spherical mark right there. We're going to call that a benchmark. It's a known position or a known location, a starting point, because you can't find the elevation of any point without knowing something about where you started. So somebody already established this and drove something in the ground with a little bronze dome and put a note on it that was the date and the elevation above sea level. So we know, because somebody else did it, that the elevation above sea level is 246.54. So that's where we're starting. So we go to our calculator, we put in 246.54. I'm starting there. Now, we put somebody standing here with a big measuring tool, big ruler that's 11 feet long. You know, this person is like, you know, right here, standing there, doing all this work, hanging on to this thing. And we put a surveying instrument called a level, dumpy level, surveying level, farmer's level. Very simple tool. Much simpler than the kinds of tools used by more sophisticated surveying, but this gets the point across. That surveying level is placed somewhere between the point you know and the point you don't know, in such a way that you can look back and see a rod held on each one of those points. So in this case, we're going to start. We have to have at least two people, but there's somebody here, and that person is looking in that direction beginning, and looking in that direction, sights through that telescope, magnifies the ruler, and they can see very precisely exactly what line on that ruler, or on that rod, lines right up with the instrument, which is level because it's got a level built in and you know that it's level. It doesn't make any difference where this is as long as it's stable. As long as you have 3 points of contact, that's a stable instrument, and as long as you can level it using the level that's built in, you can look back and you can know that the height right here is exactly the same as the height right there. The height right there is 4 feet above the known position. That's our known position, so we're just going to go over and add 4. That gives us 250.54. That means the height of that instrument right there, HI, height of instruments, is 250.54 because it has to be the same as this elevation right here, and that elevation right there is simply 4 plus the known position. Now this person goes, yeah, well, I'm done now looking in that direction. So now comes over here, puts his eyeballs here, and looks that way. That direction is the foresight. The other direction is the backsight. Looking back, looking forward. Now we know the height of that instrument is 250.54. We know it's level. We look over and somebody else, or the same person, runs around and does that. So somebody else is over here holding on to that rod. You look across and you can see that your eyeball with a line in that level lines right up with a 10. Well, that means you're 10 feet above this point. You know that you were at 250.54. That point you're looking for is 10 feet below that. So you come back over here, subtract 10, and you get 240.54. 240.54 is your unknown elevation. Now let's go through and do one of the practice problems, the one that's on that first sheet. Once again, we have a benchmark. Benchmark in this case is 462.65. I'm going to come over here to the calculator and put in 462.65. 462.65. That's our current elevation, 462.65 feet above sea level. And that's our starting point, little benchmark right there. We know that elevation because somebody else has done it. We're looking for the elevation over here. You can see that it should be higher than the elevation we have. But in order to figure out exactly what we have, what it is, we need to go through the same exercise we did before to find a single elevation, but then use that first one, what's called a turning point. Turn to find the next turning point, to find the next turning point, to find the elevation. Surveyors will do this hundreds of times, especially if they're doing terrain that's hilly. And they'll do this all day long, every day for weeks and weeks and weeks. Now, in order to find the next turning point, first we have to set up a surveying tool called a level. Sometimes a dumpy level, a farmer's level. In this particular case, it's a very simple tool. It's got a telescope. We can look and see very precisely where the lines appear on these rods, which are basically big rulers. And there's a level built in, so we know we can level it. If it's level, we can use the telescope to look in one direction, the back sight, turn it 180 degrees so that we can look in another direction and know that the two things we're looking at are at the same elevation because this instrument is level. So we start with 462.65. We do a back sight with that survey tool. The number 3.9 lines right up with our target. So over here we add 3.9, and now we have 466.55. That's the height of the instrument above our benchmark. So we write that down in our little book so we don't lose track. And know the elevation of the instrument, or the height of the instrument, is 466.55 feet above sea level. Now this person comes over here, or somebody else is there. This thing swings around so you're looking forward instead of back. Set it on top of the point we want to use as a turning point. We need to know what the elevation at that point is. We read 10.8 off that rod. That means that this level is 10.8 feet above that point. If we know the level's at 466.55, we just have to subtract 10.85 in order to find out the elevation of that turning point. That's 455.7. Is that all it is? Yeah, 0.7. Now that's the elevation of this location right there. Now we're using that number to get this. Now this number comes from the next site where we take the surveying tool and we just carry it over up and down and we put it over here instead. Now looking back for a back site, we see the number 1.56. You know, 1.56 is how much higher the tool is, the surveying level, than the benchmark that it's sitting on. At this point it's not a benchmark, it's a turning point. So that turning point is 455.7, so we're going to have to add 1.56 in order to find out the height of that level. The height of the instrument is now 457.26. Now we turn the level around and we look back this way. And somebody goes running over here and they set up a rod on this one. That rod has to be level, a plumb by the way, so it's vertical. The next thing we're doing is looking for the next turning point 2. We know the height of this. We can look and see that's going to be a little lower than this one. How much lower? 2.88 lower than the height of the instrument. The height of the instrument is 457.26. Subtract from that 2.88, which is the number we're looking at when we look over here with the level. So subtract 2.88. Now we have 454.38. We'll just do like a reality check here. Is 454.38 a smaller number than what we had over here? And it is. It drops, not a lot, but it drops, so that's logical. So we're going to keep going with our logic test and just write here 454.38. 8. Don't forget to write these all down. Don't try to keep them in your head, or don't try to just let the calculator keep track of them for you. Write them down. That's what you would do if you were doing a survey. Now, once again, somebody has to go over, move the instrument, so it's over here between the turning point and the next turning point. We know the elevation right here is 454.38. We set up our instrument, we level it up, we do another back sight. That lines right up with the 10. That means we know that this instrument is 10 feet above that point. That point's 454.38, so we simply add 10 to that point and get 464.38. That becomes our new height of instruments. So right up here we're going to have 464.38. Height of instruments, swings it around. We do a foresight now, looking back at our next turning point. Somebody goes over there with a big ruler. The ruler is set right on top of that turning point. And we go, all right, how much lower than my instrument, how much lower than that surveying level is that point? We sight across and we see 3.25. So that means this point is 3.25 feet lower than the instrument. We subtract 3.25. That gives us 461.13. 461.13 is our new turning point height, new elevation. Again, if we check the kind of reality of this, it says, you know, we're getting back up now, so we're a little below the benchmark, but we're getting up close to it. Yeah, those two numbers are close, and this one is lower. That's probably right. Now, once again, take the survey level, bring it over here. We need a new height of instruments. We do a back sight, comes back here. We look at the rod. The rod reached 9.72 feet above the end, which is sitting on a turning point, which is a known elevation of 461.13. So we just have to add 9.72. Add 9.72. We now have a new height of instrument. The new height of instrument is now 470.85. Now, we want this. That's our unknown elevation. So what we're after is we want to put a number down here that represents that elevation. We know this, 470.85, height of instruments. We do one last foresight, nice and level, goes over here, and we see that we have the number, I can't quite read it. We see what we have for a number is 3.8. That means that the elevation of that point is 3.8 feet below, that way, below the height of instruments. We go back over here, subtract 3.8. Make sure you can see all that. Say, what does that equal? And then the answer down here is going to be 467.05. Now, you don't have to draw all these arrows in. This is just for me to kind of point out to you what's going on here. You don't have to draw little people standing and holding it either. What you do have to do is fill in every single blank. And every time you do, you ask yourself, is that logical? Height of that instrument? Yeah. Oh, yeah, it's below that. Okay, it's a smaller number. Up here, well, that's above our starting point. I can look back and see that. Boy, that better be bigger. Yeah, that's bigger. So if you just keep asking yourself that, the chances of you making a mistake are far less. Now, that was the information sheet that showed you how to do it. That had a practice problem. This is the first of the 4 that you need to do for the worksheet. I'm not going to go through this and do it. What I am going to do is this, just kind of remind you of what you're doing, and then I'll tell you what the unknown elevation is on just this one. Then you fill in all these numbers and see if you get that number. Start by clearing this off. Now, what this means is this is starting at a curb on a road. Roads have a crown, so that's a cross-section of the road. There's a curbing right there, and somebody has already determined that the height above sea level of that curb is 846.54 feet. You don't have to put a foot mark, it's just that we know that. You then need to use that value, and these are the rods, and all the numbers given to you are the variations or the gradations on that rod. So the tool's looking back, the surveying levels looking back, sees a 6.3, that's how high it is above the benchmark. From there, you just keep going to a turning point. height of instrument, turning point, height of instrument, unknown elevation. Now I'll do the calculation and I'm going to show you what the unknown elevation is. Then you can use that to check your work and then do the others. And there's your unknown elevation.